Hi, everybody. This is the start of your virtual star party for June 17th, 2012. And tonight, actually nobody's even watching, so, but this gets saved to YouTube, so I have to still give my spiel. So what has everyone got? Did I get that right, Gary? Is that what you've got? M3?
M3, that's correct.
Yeah, okay.
Yeah, it's a real tight one.
Yeah. I will give you your code for the for YouTube if you want to bring that into the Hangout comment tracker. And then, did you want to share it, Scott, over on the virtual star party?
Yeah,
okay.
I'm sharing it on my page right now, and I'll get it on to VSP.
Okay, awesome.
And I'm trying to hashtag Science Sunday too, so we can get some more non-normal followers.
Yeah, what hashtag do you want to be using, Fraser? I think we're using Star Party as our hashtag.
Star Party?
I will edit the website.
Star Party is the hashtag. We've got just a handful of people watching right now, so...
Hi, handful of people.
Hi, handful of people.
We're in the process of tweeting, sharing, doing all the different things people do across all the different social networks. If you want to join along, please share along. We could really use your support getting the word out about what we're up to.
All right.
Okay.
Okay, good. Well, then why don't we get cracking then for the for people who are watching right now. So, hi everybody. My name is Fraser Kane. I am the publisher of Universe Today, and this is your virtual star party for June 17th, 2012. So tonight we've got a couple of live astronomers and a couple of people who are going to be showcasing some images they captured just earlier tonight, actually. So the first person who is showing us a live view of the sky right now. Oh, I'm getting some echo from Howard. I'm going to mute him. Okay. The first person giving us a live view right now is Gary Gonella. Hey, Gary, how's it going?
Hey, okay. This is M3, which is in a good spot for me. It's almost straight up. So I'm shooting through the least amount of atmosphere. Kind of hard to see the scope there, but...
oh, yeah, okay. I can see the telescope pointing straight up.
Yeah.
No, it's perfect.
So that's a good spot. So this is a globular cluster, and Pamela could tell us a lot more about it than I can.
Well, let me introduce everybody else first before we get too far into it. So the other person who's there is Howard McCulsey. Hey, Howard, how you doing? Oh, I actually muted Howard, so I was getting some echo from him. So once he realizes that I've muted him, he'll say hi. And then the other person that I've got here is Mark. Hey, Mark. Oh, I've also muted Mark. There's like clicky noises coming from your computer, so I had to mute that.
Hello, I'll say hi again.
There we go. All right, cool. And we've got Mictchell Duke, who's got a live view of Saturn. Who had a live view of Saturn just a second ago. Oh, there it is. So this was, and we're going to show some video he took like just a couple of hours ago, and it's absolutely gorgeous. So Mitchell's in North Carolina. Hey, Mitchell.
Hey.
And then of course for color commentary we've got Dr. Pamela Gay, my co-host over at Astronomy Cast, and we've got Scott Lewis. Virtual Star Party. If those don't remember, Scott was one of the people who was handling the transit of Venus down in San Diego, and was doing a phenomenal job. Totally sunburned, but just did a great job showcasing. Had the cool hydrogen alpha filter on the Coronado, which was just beautiful, and also handled all our coverage for the solar eclipse. So Scott has been a total stellar part of the Star Party. So it's been great. Cool. All right. Okay. So, and then just to warn you, I've been out on the water all day. I'm completely fried. That's why I'm this sort of red color. I get really fried in the sun today. So, all right. Well, let's go back around and we'll talk to Gary then, and we'll get a sort of a more in-depth look at what we got here. So, Gary, what's going on?
Okay, we're on M3, and like I said, it's a good shot for it right now because it's almost straight up. It's a globular cluster, and I'll turn it over to the people who know to talk about this.
So a globular cluster is a group of stars that all formed about the exact same time out of the exact same cloud of material. So the only thing that differentiates one star from another on the grand scheme of things is their mass. So these are fabulous stellar laboratories where we have the chance to look from one globular cluster to another and see two systems that all the stars in each system formed at the same time. So they're all the same age, and we only have to deal with a couple of variables, and we use them as ways to say, okay, a cluster of stars this age looks this way, a cluster of stars this age looks this way. And for the most part, because these were among some of the first things formed in our galactic neighborhood, they're extremely old, 12 billion years in some cases. And so they're all very metal deficient. They don't have a lot of the things that you need to form planets, so we haven't managed to find a planet in a globular cluster yet. But they have a soft spot in my heart because they're one of the first things that I studied as a researcher.
Yeah, me too. Well, not as a researcher, of course, but as an amateur astronomer. The globular cluster in M13, which I think we're going to try and find shortly, is one of the ones that I looked at first. Now, Dustin Michael Jackson asked, what program is that, may I ask? So you're going to have to be more specific. Are you talking about the telescope, the software they're using to display into the Hangout? So if you can let us know exactly what you're talking about, we can sort of point you in the right direction. We're using, so there's a bunch of different telescopes. Gary has his 16-inch telescope set up in an observatory just outside his house, and has software to bring the image into his computer, and then he's able to broadcast that into this Hangout. And then you can see what Mitchell Duke is doing. You can actually see his software there. And you can see, is that still the current view of Saturn, Mitchell?
Yeah, it's a live shot. It's even got a little bit better. It's only 20 degrees above the horizon right now.
Yeah, that looks beautiful. So what is the software that you're using to control this image right now?
This is Fire Capture. It's actually made by Honto, who is an amateur astronomer.
And you're running Linux, right?
No, Windows. Actually.
Oh, you're running Windows. Okay, all right. So there you go. So
right.
It's called Fire Capture, made by Honto, and this is the view. And we can, in a second, like we'll keep watching Saturn while we can, and then when we lose the view, we'll go back and look at some of the video that you captured just like a couple of hours ago, and it's just gorgeous. Now, do you think that you'd be able to pick out one of the moons?
I can give it a shot.
Yeah. So one of the things that sort of you don't realize is that the brightness of the moons are very different from the brightness of the planet. And so for us to be able to see Titan, for example, you've got to oversaturate the brightness of Saturn itself, and then you can see some of these dim moons if we're lucky. Other times you can't see it at all. So that's what Mitchell's going to try and do is brighten Saturn. Let's see if we can see one. I don't see a moon.
I can see them on this side, but you can't see them.
Oh, you see them in your own view?
Yeah, we have. Let me see. Let me take that off. There's one right here, and there's one right here.
Oh, and they're just not coming through.
Yeah, they're just not coming through in the Hangout.
You'll be able to see them plain as day.
Yeah, it must be the compression of the video.
Yeah.
Yeah.
They're just too few pixels.
Oh well. Let's go back and see just the regular Saturn, and that way we can appreciate it for as long as we can before it's gone. Oh, that's beautiful though. So, hey Scott, have you done any observing of Saturn? What are you seeing here?
Have I recently or ever?
Yeah.
Recently, no.
Ever.
I've seen Saturn through quite a few telescopes, and it's wonderful. Lately, no. I've just finished up 5 of my finals, so this is my relaxation weekend before I go on to researching. So, but no, that is a phenomenal view, especially being able to send it through with the video. I'm loving it.
So, what are some features that we might be able to see? Depending on if it's a really good telescope.
Well, right now you can actually see it here. You can actually see the Cassini division within the rings, which I believe Mictchell's pointing out there. So you're actually able to see a division of where you can actually, the light's going through instead of being occluded by the dust and the ice that are around Saturn's body, the gaseous in the middle. And you can actually see, it's just moving a little bit, but you can actually see the shadow on the rings themselves, which is gorgeous.
Yeah. I can see some bands across the planet there, too.
Yep.
All right, this is terrible seeing.
You're doing a great job, Mictchell. You really are.
Yeah.
Thank you.
So what's really neat about this image is you're really starting to be able to see the rings opening up. Back in 2009, the rings were completely edge-on. And so it's nice to get our good old pretty view of Saturn back over time.
Yeah, right. That's right. Because they were like this, right? And then and now they're more like that again.
It's just like a slow motion of what the Earth does. I believe it's 29 years for it to go around its orbit. So it's the seasons that are over 7 years long, and we get to enjoy each angle as we're going across, being able to look similarly at what it was the day before. It's not going to transition as fast as if we were looking at a closer planet like Mars.
And what's awesome is with Cassini orbiting it got there right before the last solstice, was there for the equinox, and now it's on its way to getting to see another solstice again. So it's going to get to slowly see summer, winter, and spring, basically.
That's cool. So, but the video that you just took just like an hour ago, and the other thing we'll do is like, I don't know, Mictchell, were you planning to post some images later on too?
Yeah, I already have one up. Actually, I have an IR shot.
Oh, do you? Is it on your Google Plus stream?
Right.
Okay. Yeah. Yeah. So if anyone has any questions, any requests, go ahead. You can, if you're watching this on Google Plus, you can post a comment into the Google Plus stream where we're broadcasting this. If you're on YouTube, you can just post into the comments on YouTube. If you're watching this on CosmoQuest or anywhere else, you can just use the hashtag StarParty, and we'll catch that as well and be able to answer it. So this is live. So if if there's something you want to see, we'll try and find it. Unfortunately, right now we're just at a new moon. So we're not going to be able to show the moon tonight. Mars has gone down. Venus, as you know, just passed in front of the face of the sun. So, although some people are starting to catch Venus again in the morning now. So now maybe some of our European and Asian astronomer friends will be able to catch it for us, and if they get up in the morning. But Venus and Jupiter are visible in the morning now.
Wow.
And Mars is down. And the moon is, like a little sliver.
So I threw up a Venus transit picture I took the other day when it was going across. This was also through the Canon T3i with my Meade telescope. Funny story is you got to be very careful with your finder scope when you're looking at the sun. I didn't have a cover on mine, and it melted part of my LED red dot finder. So now my red dot is kind of a red blur.
Ooh, yeah, any observing the sun. But I mean, that's what happens, right? Is you think about the main telescope, but you forget about the finder telescope, and it's like a little laser beam focusing the light of the sun just really close to where you'll be looking through.
It's not like a laser green. It's like that magnifying glass you use to fry ants.
Yeah, it's going to be frying your eyeball. But the point being that it's very close, right? You're going to look through where you look through the main eyepiece of the telescope and be really close to the finder. And it's such habit that you're going to be looking through the finder and looking through the main eyepiece. I'm sure a lot of people burn a hole in their eye just by looking through the eyepiece and then through the finder scope accidentally. So check this out. This is the video that Mictchell captured about a couple of hours ago. That is just fantastic.
It's amazing how much the weather's changed. just such a short period of time.
Well, it's also just a lot lower on the horizon now.
Yeah.
So it's only just
15 degrees. 20. That's my app site.
Yeah, it's beautiful. So Quirasdiff970 wants to know where the telescopes are. So Gary Gonella is in Los Angeles. Howard is using a telescope that is in the Canary Islands. Mark is in Chicago, right? And Mitchell's in North Carolina. And then Pamela, you're in Edwardsville. Scott, you're in LA as well. And I'm on Vancouver Island. Any chance, Eddie Ledbetter wants to know, any chance of getting Dr. Porco to join a star party if we haven't already?
She's very, very busy. We can ask, but I think we're more likely, instead of getting her to join a star party, to instead join one of our weekly science hours, which are every Wednesday at 4 o'clock Pacific, 7 o'clock Eastern, U.S. time. These are conversations we have with scientists where we let them spend the entire hour talking about what they're most passionate about. And I think with her busy schedule, that would probably take better advantage of her time, and I will go ahead and contact her about that.
Yeah, the invitations are always open. You know, a lot of people want us to get Neil deGrasse Tyson here too.
Yeah.
You know, he's so busy. So, all right. Well, let's come back around then, and let's take a look at what Gary's got this time for us. Gary, what do you have for us now?
Hang on, got to unmute myself. This is something I haven't looked at before, so this is the first time. NGC 7023. It's known as the Iris Nebula, and that is a 2-minute exposure.
I've never looked at the Iris Nebula before.
I haven't either. I just
It's cute.
come up with it.
Yeah, it's really pretty.
I'm going to have to do some narrow band and turn it into a color one. That's got to be on my list of things to do.
Yeah, I'm looking at some other images of it, and it's really an interesting. The Iris Nebula itself is really formed. It's got an interesting structure. If you can see right above your main amount of light, you see this almost blobby triangle. And yeah, I'd like to see some more of your images of that later, Gary. That's a really interesting nebula there.
Yeah, this nebula isn't like most of the ones that we look at, which are illuminated by having hot stars embedded within the gas. This is instead a reflection nebula that it's also known as Caldwell 4. So Sir Patrick Moore is responsible for putting together the list of pretty objects that it sits on. And it's basically reflecting the light of nearby stars, and so that light appears blue because most of the blue light is getting scattered in a random direction while the red light passes straight through the system. So were we able to see this in other colors of light, it would dominate in bluer colors.
So I'm screen sharing a view from somebody. This was on Wikipedia. So this is what it would look like in full color with a long exposure.
And it really does look like an iris in that image.
Yeah.
Yeah, reflection nebulas are kind of awesome, and if you ever want to try and understand how they work, take a flashlight and a 2-liter soda bottle and put just a little bit of milk powder, like that nasty, awful powder that you use as fake cream. Mix it in with water in that 2-liter container, and if you try and shine a flashlight straight through, when you look at a right angle to the flashlight, the milk will appear slightly bluish, and when you look straight through it, it appears reddish.
And why? Oh, because it's getting...
It's the scattering.
It's the scattering. Kind of like why the sky's blue.
Yeah, it's all the exact same scattering principle, why the sky is blue, why the milk appears blue, and why the Iris Nebula appears blue.
TM Nanth wanted to know what was the NGC number of that. It's...
NGC
7023.
Yeah. 7023, Caldwell 4.
There you go. That's beautiful. That's great. I would love to see you do some pictures of that, Gary.
Yep, I'm going to have to do that.
And you've never imaged this object before?
I have never. There are so many things up there that...
It's amazing to me. You've got this, there's every week, there's like, oh, and here's something I've never seen before, but, let's take a look at it.
Yeah.
So Howard, what have you got for us here? No, I wonder if he's still muted.
I'll shoot him a message.
Mute everybody.
Maybe.
Yeah, I know. I'm very aggressive on the mute.
We love you anyways.
But we get this. So Mictchell, this is the final image that you took of this, right?
Right.
Wow.
Actually, that's the infrared shot. I just processed a red shot just then, and it's actually better than that.
So can you explain that process? When you say you process an image, can you sort of explain what goes through, like how you do that? Because, I mean, this is phenomenally clear image, right?
Right. Well, the first thing I do is I take an AVI shot of each one of the color channels, which is red, blue, and green. And,
so like a video, like you record a video.
Right. Right. Anywhere from 65 frames per second to 30.
Can you zoom? Sorry to interrupt you. Can you zoom it a little bigger? Because I can see the little zoom in the bottom left of that window. Can you dig in it a little?
You can see that.
Oh, maybe that's not a zoom.
There
we go.
Yeah, cool.
There we go. Okay, thanks. Bigger is always just better. Sorry. So you record the video in each color channel.
Right. Then we take a program that's called Castrator. Don't ask me where it got its name.
It's a little traumatizing.
And
Wyoming working with sheep.
It centers and crops the actual image. So that way we can stack the image and make a very sharp image off of the best frames.
So it's like pulling every image of Saturn out of every frame of the video and then aligning them all up perfectly.
Right.
Yeah.
Only the best ones, though.
Only the best ones.
About 40%. So basically, the red channel, I got 6,000 frames. So I'm using roughly about 4,000 frames to put that one together.
Wow.
Wow. It's a stunning image.
That is beautiful.
And that's only in one color, so you'll then stack up the three colors together.
Right. So roughly we'll put together about 7,000 frames to make one color shot, which is probably around 10 or 12 gigabytes per shot.
Wow. And then you throw all that out when you're done with it.
Right.
You free up your hard drive space.
Well, that's why I have a portable hard drive that holds about 1 terabyte or 2 terabytes.
Yeah. Fill it up every night and then process it all and get it and empty it all back out again.
Right. Let's see. I'm going to post a red shot.
That's phenomenal. And then, so will you be posting a color image later on?
Yes. Yeah,
Okay.
and this one here, it should be really good.
Okay, yeah, no, I mean, the individual pieces are so nice.
And this is why you should follow all of these gentlemen on Google+, because I saw this image earlier on Google+ when Mark posted it, and it's just a chance to drink in amazing images.
Yeah, so that's Mictchell Duke. I'll share my sort of everyone in the star party at some point.
And here's red.
Right. So it's hard to see the difference.
You can see the banding right here.
Yeah.
Well, actually, there's tons of bands on this one. Let's see. Let's flip it. You can actually see the bands better if you flip the image.
Psychology is awesome.
Oh, so like your brain sees it better when it's flipped?
Yeah.
Are you able to hear us, Howard? No, you're still muted. Cool. All right. Well, let's. So if you can build, I mean, can you build a color one while we're waiting?
Yeah, sure.
That would be amazing. Thank you. I know you're like out with your telescope right now, so I know it's sort of. But that would be really, really cool to show everybody how this works.
You get used to it.
So Gary has a new little, it looks like a planetary nebula that he's showing us. What object is
we can hear you, Howard.
Okay, good.
Yep.
Welcome back.
Cool. I'll bring up something else.
Yeah, that'd be great.
M27, the dumbbell.
Oh, great.
Really
one of
beautiful
the
in color.
primary, most awesome planetary nebulas for amateur astronomers to observe.
What's the designation again?
27.
M27.
So
So
obviously
this
I
is-
have looked at that one before.
Yeah, I think I have too.
This is basically the future of our sun. And
Oh, really?
if you could see this in full color, it's bright green with red around the edges.
But isn't it all just false color?
No, actually, it's green from the oxygen lines. So these systems have excited oxygen, and oxygen appears green. So planetary nebulas are one of those things that crop up as green all over the galaxy.
Here, I'll show you that. So here's the same image taken by a monster telescope in Chile.
Yeah, my guess is that they probably used a oxygen filter to get the really green, a hydrogen filter to get the red, and maybe sulfur or something to get yellow. I'm not sure. But that's probably narrowband imaging that made it look so dynamically colorful.
Yeah. And so we'll just compare. Is this one that you took before?
Right, with regular color. This is a red, green, blue filter when I was in a dark location.
Wow, that is gorgeous.
I told you they're green.
Well, it's kind of bluey, but yeah.
Yeah, they're awesome. Planetary nebula, trying to make sense of them was actually one of the motivating factors for building the Hubble Space Telescope. Because there's all these weird shaped blobs on the sky that are all, we know that they're planetary nebula, and trying to figure out where all their strange structures came from took the high resolution of the Hubble Space Telescope.
Oh, this is great. Look at Mark's. Mark, is that your Saturn?
No, Saturn's gone for me. I just pointed it at Arcturus, and so this is just what a star looks like. It twinkles nicely.
That's good.
It twinkles violently, I think maybe more like it.
But you're in such a light polluted area.
I am, and it's like 90% humidity out, and it's muggy and hot, so not the best seeing tonight.
You can just see the full width half max jumping all around. The full width half max is a way of describing how sharp the image is, where they look at it's brightest in the center and then it falls off in a curve, and you look for what is the full width of the light at half its maximum value. And that's the full width half max, and the smaller that number, the sharper your image.
So we got a request. We got a request for M17. But it should be up. Yeah, the Swan. It's in Sagittarius. I don't know if that's a little low for you still.
Yeah, it's
Gary.
probably low.
Yeah,
Didn't we get the Swan a couple of weeks ago though? Sort of later on in the evening.
I think we got it in one of the very first star parties.
Oh, so just as said, last like a year ago. Well, back in October maybe.
Yeah, October, November time frame. What's
Yeah, towards the end of the summer, that becomes easier.
Yeah.
It's pretty low for me. Sagittarius is pretty low on the horizon still.
So Alan wanted to know what software he's using. So Alan, you want to know what software Mark is using? Yeah. What are you using, Mark?
The software is called Backyard EOS. It's by some guy in France, I believe, and he's just I follow the forums on it, and he's just super responsive about bug fixes and everything. But it's designed specifically for Canon cameras to hook up the USB port and pull the live view data off of it onto your computer, so you can set up an imaging plan. I'll flip over here. So you can set up as many exposures as you want to do, whatever the time, different settings, and you just let it run, and it'll run all night and do whatever, carry out your imaging plan. Or there's a planetary mode which records AVIs.
It's worth noting it only runs in Windows, but you can force a Mac to run Windows if you hate yourself, which apparently I do.
Why all the Windows hating?
Viruses.
I'll keep my mouth shut.
But yeah, no, I mean the Canon cameras, and I'm sure the Nikons as well, are fantastic astronomy cameras. And so if you've already got like a DSLR, like a Canon DSLR, even one of the older ones, there's a lot of people that use like the first EOS. It's a fantastic. It's got a really great CCD. It's a great use for doing astronomy. And so, but software like this, the Backyard EOS, lets you then record these, like what Mictchell was doing, right? Mitchell's got a very specialized piece of software and a very specialized astronomical camera, but you can take what is a really good DSLR camera and be able to connect it up to your telescope and get a view. So if you've already got a DSLR and you want to get into astronomy, especially if you want to get into astrophotography, you're actually already 75% of the way there. You can get what kind of telescope are you running, Mark?
Mine's a Meade ETX90, so it's very small, very portable, and also, more importantly, very cheap telescope compared to what some of these other guys have. And like you were saying, my camera does double duty. You know, I bring it on vacation. I take snapshots with it everywhere I go. And, you know, when I want, I just throw it on the back of my telescope, and, you know, I try and get some images.
Just imagine your telescope as a really big lens, a really high-power lens.
And you can actually, one of the things that I'm looking to do is, rather than breaking down and buying a telescope that I'm not absolutely in love with, getting instead a 300-millimeter lens, which will allow me to do a fair amount of wide-field astrophotography.
And one of my friends also has a tabletop equatorial mount for his camera, so he can put his camera on there with his 300-millimeter lens, and he's got some, you know, very decent shots of the Milky Way where he's got 5-minute exposures, and there's not, you know, the stars don't shift at all.
Right.
Oh, it's tracking really well that entire time.
Yeah, because you're going to have to buy a mount no matter what you get, and if you get the 300-millimeter lens, well, you can do so many other things with it.
But that's a monster lens, right?
It is.
They're really heavy.
Yeah.
Yeah, like.
Yeah, I can show you some shots of the moon I took the other night through the 300-millimeter lens, just to get an idea. Let me flip through my Lightroom catalog here.
Mictchell just put a color Saturn up.
Make it bigger, Mictchell.
I can't quite yet. This is the process in software, but if you look right here, you can actually see a moon that popped out on the image.
Oh, that's beautiful. Bigger, 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 bigger. I'll wait till it's bigger. All right.
And Gary has the Crescent Nebula.
I do.
That's cool.
And this is, I've even got some of the hydrogen all around the crescent. There's a lot of hydrogen gas that's glowing. You can see it in these areas. And
so if people want to find the Crescent Nebula, what's the designation for that?
NGC 6888.
And it's also a Caldwell object. It's Caldwell 27. And this is the exact opposite of the image we looked at a few minutes ago, which was a reflection nebula. This one is instead an emission nebula, which means that there's a bright, hot star in its center, and that star is causing the gas around it to glow. And the bright star in the center is actually a Wolf-Rayet star, which is a star which will probably eventually, depending on the amount of mass loss it suffers, will probably eventually go supernova. So this nebula is just beginning. It's going to go through all sorts of dramatic evolution over the next 50 million years or so.
And have you seen this one before, Gary?
Yes, this is a false color I took of this one. So this is with narrowband, where hydrogen is red, sulfur is green, and oxygen is blue.
It looks like a space brain.
It does.
You've been watching too much Futurama.
Yeah, clearly. Maybe not enough. So this is one that I just pulled off of, you know, again, I'm going to compare one from the Hubble Space Telescope to a picture that Gary is taking right now.
I want one.
You want your own Hubble?
Yes.
Yeah.
All right, I'll go halvesies with you on that, Gary.
Yeah.
Okay.
The military just gave 2 of them away.
I know. They found 2 telescopes they're able to use.
We're
Amazing.
still trying to. The
I love-
astronomical community is still trying to figure out how to use them. It's going to be fun to watch.
Well, don't they have like a really wide field of view? Much wider than any of the other astronomical telescopes, and that's good because it's just different, right?
Yeah, they're still they didn't come entirely for free, so it's going to be interesting to see people going, but we want them, but we don't have money for them. So they'll be an interesting 6 months.
Because they've got to
panic.
fix them, and then they've got to launch them, and yeah.
Yeah.
And then
Always
had
look
it.
a gift horse in the mouth because the teeth can be expensive to repair.
Yes.
All right, well, Howard, can you hear us?
Yes.
All right,
You
what
hear
have you got? Yes, I can
This
hear
is-
you. What,
Yeah, this is the Swan Nebula, M17, and this is at again the Canary Islands. This one I took yesterday because I'm past all my reservation time on all of my telescopes that I'm using tonight. So this is a 0.35 millimeter, 0.35 meter reflector, and it's a pretty nice picture, I think.
yeah, so like a foot, like a. I'm trying to think what
Yeah,
that is.
I can't see the swan, but
Oh, here's the color Saturn.
Beautiful.
That is beautiful.
Wow.
And one of the things that scientists are really loving is as the seasons change, storms and bands change and change colors, and it's actually been amateur astronomers who've been largely noticing the large bands emerging first.
We got a request for M20.
Is that too low for you, Gary? It looks like it's getting higher up in the sky right now.
Yeah, we've lost
Trifid?
M20. Yeah, Trifid.
Yeah.
Yeah, we were able to get beautiful views of the Trifid Nebula back in December, January, but now it's just too late in the season.
You just need to keep watching our star
Gotta
parties
keep watching-
until the
or you
Earth
can-
gets back around the sun.
Yeah, or you can watch some of the other ones that we did because we actually did get it quite a few weeks, and we all oohed and awed because it's one of the best objects that Gary was able to deliver to us. Bigger, bigger, bigger.
Oh. Trying to get it perfect.
So just to sort of recap for everybody, right? So Mictchell is live right now. He took video of Saturn in 3 different wavelengths just over the last couple of hours, and you saw some of it live, and you saw some of the video of what it looked like live, and then he sort of took one video for red, one for green, one for blue, and then he compressed all those videos down so they were just a single image, the sort of best of, and then merged those 3 colors together, and this is the final image. Although I'm sure he's going to then bring it into Photoshop and,
Oh yeah, it's
going.
not near done.
You
Yeah.
hook up to your 3D printer too and hang it up from the ceiling. And
That's probably Jupiter this year. But if you look in this little square right here, you can see one of the moons. If I can try to bring it out some.
Yeah, I can't see it through the Hangout.
Oh, really?
Yeah.
No.
Yeah.
Oh, there it is.
There.
Oh yeah. That's fantastic. Yeah, I totally see it.
I have no clue which one it is.
That's what Stellarium is for later.
Yep. And actually there's, let's see, 1, 2, 3.
How long did it take you to build up your color image?
If I focus entirely on it, probably 10 minutes.
Okay, so the moons don't have time to move very far.
Right. Oh, to actually make the actual video, it's 6 minutes.
Yeah, okay.
They're not moving that fast. I think I see another moon off to the right.
Right here.
Yeah.
There's one here, here, and here.
So the bright one is probably Titan.
It's got to be, especially that size.
Yeah, you can actually see almost a disc on it. Although it could just be the light.
Like hopefully this year with Jupiter we get Ganymede and you can actually see detail in the moon a little bit.
Wow. Alan Curlin just posted some pictures of the Venus transit on his blog, so you should check that out. It's in the comments on the Google Plus stream, and I actually just took a look at them, and they're beautiful. So nice work, Alan. Cool. With a Dobsonian too. So that's hard work to get really good astrophotos with a Dobsonian, because you're having to track manually, which is what Mark is doing.
There are Dobs that will track electronically, but very few.
All right, let's go back to Gary then. So Gary, what have you got now?
This is Gamma Sig Nebula. This is the 10-second. I'm 40 seconds into the 60-second exposure right now. This again is one that I haven't imaged before.
And so what was it again? The Gamma?
Gamma Sig, CYG. So it's in Cygnus, I'm assuming.
Yeah.
Yeah. And that's one I just, sat down yesterday and just went through the star charts and said, what can I find? And found several things that I had never seen before.
So this is part of the North American Nebula, which is this giant patch of hydrogen that when you view the entire thing, looks like North America. But the Gamma Cygni part of it is around the star Gamma Cygnus, which is one of the brightest stars in the constellation Cygnus the Swan, which is part of the Summer Triangle. Now, to me, color fancy images of this look rather like a nasty sea monster about to come out and bite you. So I don't know if your image will bring out the whole upper and lower jaw getting ready to bite you quality of this nebula.
Okay, that's the full 60-second exposure.
Okay.
And that one's mostly hydrogen.
Yeah. And where you see the occasional black, what look like termite trails through the glowing gas, that's where there's really thick material blocking the light of the background stars. Yeah.
And I will deliver another sort of high-resolution photo. But you've never. But you've.
Gonna do it, but okay.
You're gonna do it?
Yeah.
Race, yeah.
Yeah. Scott's looking at the same one I'm looking at.
I think we all are.
And doesn't that look like the eye of a sea monster that's about to bite you, like one of those Monterey eels or something?
Oh, Scott, I recommend that you use like a different image. Don't try and bring it up in the browser if you can. Bring it up in some other method, like a preview tool or an image view.
I can do that, sure.
Yeah, it's in the future, just because the browser sort of makes it smaller.
And this is also one that is too wide for my field of view.
Yeah. Which is impressive considering how large your field of view is.
Yeah.
The North American Nebula, you really want to be using a camera piggybacked on a telescope to take images of. So
there's, trying to get the rotation then.
Rotate it 90 to the left, counterclockwise.
No, but I can see, like in Gary's view, the star is right at the very top. And then in this one, the star is right in the middle. So I can sort of see that this is actually...
Okay. Yeah, I see where you're going.
Yeah. So Gary, have you ever tried to build up an entire image of the North American Nebula?
I haven't. That's on my list to do. I've done the Pelican, which is I'm going to move to next. I can get a good chunk of the Pelican Nebula, but I've done that only in hydrogen alpha. But one of my goals is to take the American Nebula and the Pelican and build it all up. But that gets very tedious.
Right, but I mean, I guess the thing is that you're having to actually stitch the images afterwards, right, which makes it a little tougher.
Yeah, and then you got to make sure the light level is balanced and that they fit. And I played with it a little bit, and I'm kind of putting it off.
It's more of an art than a science.
Yes.
So Howard, this is an I think this is what, M20?
This is M20, right? And I did do this earlier this evening. Another Canary Island shot. So you can see the date, 17th, 3:05 UTC. So that was before this started, obviously. But it's not. It's not up now. I think I got it right at the end of the cycle there.
This is the power of using telescopes in other parts of the world, is you get to see parts of the sky that the rest of us don't get to play with.
And by the way, along that line, it looks like the Australian at Sighting Spring will be up on this SLU, the network they have in the end of July. So we're going to be able to see some southern hemisphere stuff here pretty soon.
Very cool.
The only problem that I have is that I reserve time, and you guys don't run to any schedule, so my reserved time goes by while you're doing other things. So I can only show you what I've already got. Is what it looks like is going to happen. That's the only problem with reserved time problems.
Yeah.
And there's some more of the video that Mictchell took earlier. Are you running another render, Mictchell?
Not yet. I'm still trying to pick out the best ones.
That's cool. All right, so this is the Pelican?
Yeah, I haven't framed it. Oh, it's good enough right there. Let me. That's a 10-second on the Pelican. And,
I've never been able to find the Pelican.
You're not sure why it's been named the Pelican?
Yeah. I recognize this may be a personal problem, but...
Oh, well, let me...
I think I can see it, but...
What is, Gary, what is the, was it NGC or is it Messier or what?
I don't have any Messier or NGC numbers for it.
Oh.
It's an IC number. It's IC
okay.
5070 and 5067. It's, again, part of the North American Nebula that's just gotten its own name.
Gotcha.
And let me see if I can remember how to rotate this in this software.
I think I see why it's called the Pelican Nebula.
Here's the eye.
Yeah, there's a
mouth, the back of the head.
Yeah, I agree.
Okay.
So the mouth is right down here. It's doing the... Did I start? Hang on, I didn't start the 60-second. I'll have a 60-second here and we'll see it better.
Okay.
Doing too many things at once.
And
So
Fraser's gone and gotten the professional images.
Yes.
No, Gary is a professional. The post-processed images.
Okay.
Gary can produce images just as good as this if he took his telescope to a darker location and
That's true. That's
and
totally
did a 5-minute, 10-minute, 20-minute exposure.
Mm-hmm. And just to the
and
left,
many of them.
Yeah.
To the left of Fraser's is the North American Nebula. And way off to the left is the Gulf of Mexico, everything, California. Okay, we're coming up on the 60-second here.
You know, I'm going to say it looks more like a pterodactyl than a pelican.
Yeah, I see that.
I'll buy that.
Like a hawk. Hannah, I'm sorry, I can't even pronounce your last name, Hannah. I'll try. Pietikanen? Sorry. Says it looks like a hawk. And I see that too. I know, I'm going to go with pterodactyl. No, but I think it looks like the wings are sort of stretched out.
I can see a phoenix if you imagine it flying towards the right-hand side of the image.
Yeah,
like
but now...
flaming wings stretched out.
Totally. Like some kind of firebird blasting through flames.
I guess I'm much more Harry Potter than reality sometimes.
Or Fahrenheit 451, depending on which side you want to go on it.
Yeah.
Yes. This is a 60-second exposure.
That's beautiful, though. Lots more detail.
Yeah.
Yeah, it's
Yeah,
really...
I love all the little detail right in this area. We got the little bubbles, you know, they're,
Yeah.
what, 100 times bigger than our solar system? Or more
Something
than
like that, yeah.
you know. So that is the Pelican.
Somebody asked for the ET cluster. We've done that one before, right? NGC 457.
GC 457.
Yeah. I remember doing that. Let me see when it's up. No.
Oh, this is an open cluster. It's also known as the OWL cluster and
The OWL
Caldwell
cluster.
13.
It's in Cassiopeia. That should be doable. Just so people know, there's no tricks. This is live.
The only problem with Cassiopeia is it sometimes dips behind trees. It's annoying in that way.
Oh, here's Howard's view of the sun. Oh, sorry, view of Saturn's.
Sun.
The sun. Go look at
Light
it.
from the sun, though.
Yeah.
Yeah, and this was the last it was visible at the Canary Islands this evening, or this afternoon, late this afternoon. Was it about? Oh, it was midnight at that telescope.
That's a beautiful image. I love the way Saturn's shadow goes across the rings along the back.
Yeah, And this is one of the first times I've taken a picture of it where it was really faint. You know, it's one of the classic ways they take it. You know, it's not up on an angle or it's just nice, just straight on. It's neat.
So what's happening, people often think that Saturn's rings are doing this over time. No, Saturn's rings are always at the exact same angle north-south, but what's happening is as it goes around the sun, we end up seeing different perspectives on the rings. So it's always tilted the same amount, and then we tend to flatten it out and see it appear to do this. But no, it's really just the rotation about a single axis.
So, Gary, were you going to try and get the ET cluster?
I can't. It's way to the north and behind a mountain for me.
Oh,
What's the
really?
number?
Okay.
That's
What's the
worse
number
than a
on
tree.
Yeah.
It was NGC 457.
457. I've got mountains to the north of me, so
Yeah.
it's behind them.
Oh well. I get a great view of Cassiopeia here. I mean, people can see it's still light here. You can see out my back window right now. It's
Twilight, purple sky.
yeah. Although it actually looks nicer in the camera than it does for real.
Yeah, I have never taken a picture of that.
Alan Curlin is wondering, is there a way to refresh the comments on the Google Plus page without reloading the page? No. Well, there is, but no.
Not to them.
Yeah.
The way I've done it is I've had to place a small group, so our astronomy people, in a circle and place that circle on the G Plus stream. And so it will keep updating the comments. You just have to keep scrolling up if anybody else posts.
Yeah, and then the other way is if you go to the CosmoQuest page, you've got the comments dynamically coming in there, don't you, Pamela?
That got broken by the last update to Google+.
Oh, did it? Okay.
Yeah, so we're working to get that fixed.
Yeah, so no, you do have to reload the page, and then you got to restart the stream, and you miss a little bit. So it's
what I usually do is I open up a player in one window, and then open up another window that I refresh to track the comments.
Yeah. This is definitely a problem. We've definitely given them feedback on this, so hopefully they'll figure out a solution to this. I mean, the problem is that, although I don't want to go into a big Google Plus moan fest here, but we get the comments in 3 different places, right? We see the comments on the YouTube live, so folks like TM Nath and let me see, and Quarter Sadef 970 are commenting over on YouTube, and Lee White and Alan Curlin are commenting on Google Plus, and so we've got a plug-in in our Hangout that lets us see all of the comments and sort of sorts them for us so we can can watch all the different places the comments might show up. And actually, we didn't have that running during the Venus transit, and we had 1,300 comments over on the Venus coverage on YouTube, and we had no idea that all those comments were getting generated. So I didn't even realize, and people were like, I don't think Fraser sees us. I'm like, no. So it was like after the fact, I went looked through it, and I tried to answer as many of the issues as I could because I just felt so terrible that we didn't get all that stuff live. But that'll never happen again now because we have this really cool comment tracker. So.
And we will be working to create an integrated viewer over on CosmoQuest. We just got deprecated, so we're at an in-between stage right now.
Yeah. All right. So what have we got here, Gary?
This is M11, and this was a request. I don't know from who. When I posted earlier the ones I was going to shoot, M11 came up, and it's the last one on my list. Now, is this an open cluster or a globular, Pamela?
This is the wild duck cluster. This is an open cluster, but it's one of the more compact open clusters. It's cute, and if you get a deep enough image in the blue, there's a little bit of nebulosity left in it. There's folks that think that it looks like a flying flock of ducks that are vaguely in a triangle, so that's how it got its name.
Okay.
Do you want to try M13?
I can give it a shot.
Is that still up?
Let me see where it is.
Looked great last week. Actually, I really liked the M57 last week too, but you guys missed those.
Yeah, M13's almost straight up. So let me.
This is it. This is the best time. Summer. All the summer objects. We've been waiting for them all year, and now we're starting to get them, which is great.
I think when Sagittarius is accessible in the early evening, that's kind of primo.
Yeah. What kind of stuff do you like to see in Sagittarius?
Well, all around Sagittarius, it's just like nebula after nebula after nebula after nebula, the entire region.
Greg Grayer wants to know, is it possible to see the Pillars of Creation? Yes. Well, it's in the Eagle Nebula. We did it last week. In fact, it was hilarious. A few weeks ago, we got one image of the Eagle, and then every one of the astronomers showed their version of the Eagle Nebula and the Pillars of Creation. And so we had a couple of live images of the Eagle Nebula, and we also had 4 different, post-processed images of it at the same time. So everybody's got it. And you know what's amazing is how many sort of how visible the pillars themselves are within the nebula. So
yeah.
I don't know, Gary. While you're waiting, can you dig up an image of the Eagle Nebula, or can anyone? Has anyone got one handy?
I can.
See, last time I said it, we had 4 images of the Eagle Nebula all dug up really quickly, but oh, that's beautiful. There it is. There's M13.
Yes, that's M13.
Yeah. So Greg Chariot wanted to know who everybody is. So Greg, so what you're looking at right now, this is Gary Gonella. He's an astronomer in Los Angeles. I don't know. Can we see you for a second there, Gary?
Hang on, I got to find the right screen.
Greg Chariot wanted to sort of know who everybody was, so he knew who Pamela. There's Gary. There's Gary. And Gary's down in Los Angeles. And then we've got Howard.
Right, and I'm just near Gary. We're very close together.
Oh, are you you're in the Los Angeles area too?
Yeah, I'm in Claremont, which is about 19 or 20 miles from Gary.
Oh, okay. And then Mark, can we see you, Mark? Mark is in various stages of mountain man.
As soon as I click the right button here. I trimmed recently. I'm not that bad.
Yeah, cool. And you're in you're in the Chicago area.
Yeah, just outside of Chicago. So my skies are pretty orangish yellow all the time, no matter what.
You need a light bucket with a H-alpha filter like Gary's got.
Mm-hmm.
Yeah, I'm trying to figure out a good way of getting a light pollution filter in line with my digital camera without finding one that goes on the outside of my scope. I'm not quite sure how to put it between my scope and my digital camera.
And then Mictchell Duke, I don't know if do you have a camera of yourself? I don't think you do, right? You just have the camera.
No, I have to limit the resources
And you're outside in the dark, so. Yeah, that's the problem with the astronomers, is they're all outside in the darkness, so you don't get a good view of them. But and then Pamela, and then and Scott. And what's your story, Scott?
What's my story? Well, once upon a time.
No, but you're taking astronomy at US.
I'm at Citrus right now.
Okay.
I'm doing research at Cal Poly Pomona, starting tomorrow actually, and that's for aerospace engineering. But I'm going for astrophysics and cosmology is my major.
Cool. And like I said, Scott was one of the people who's broadcasting images of the transit and of the most recent solar eclipse. So Gary,
You requested the eagle?
yeah. And so I don't know if we can see the pillars there.
They're right. Where are they in this? Let me zoom a little bit. Right here.
Yeah.
Right. And what are the pillars? I guess Greg wanted to know what they are.
They're just large collections of gas and dust. And what's kind of awesome is this, or sad, depending on perspective, this image comes from an object that's so far away that we're seeing it as it appeared in the distant past. And we know that a supernova has likely gone off inside of this system because there's so many young stars. And so this entire thing has probably already been completely destroyed. So we're seeing something that doesn't physically exist at this moment, but its light is just arriving.
That's sad.
But what causes that pillar shape?
It's just how the stars have cleared out the different regions. So the material collapses, and you end up with cocoons of material that are forming stars inside of them. And those pillars are places where stars are actively forming and eating out the material and then blasting it apart.
But is there some kind of like wind blowing? Because almost like a solar wind, like from
the wind is what
stars?
clears out the pockets that you see.
Right.
So the pillars are caused strictly through the collapse of gas.
Right. Yeah, it's beautiful, but and like I said, it was surprising. So if we had a live view of it, you can actually see the pillars, no problem, in the live view. So.
Yeah.
I'm going to try that.
You're going to try? Why don't you take us out on a high note, Gary?
It's pretty low on the horizon, so let's see what I can do here. I should be on it right now, so let's try 10 second.
So it's a what is it? What constellation is it in?
It's Serpents.
It's not Sagittarius.
No, it's in the constellation Serpents, the snake.
Okay. Yeah, there it is.
But isn't Serpents kind of like? Oh no, Draco is the one that's everywhere. I don't see it.
Yeah, hang on. The scope didn't move.
What?
Why didn't the scope move?
Maybe you told it to go somewhere it shouldn't have been?
There we go. See, now it's moving.
That is so cool.
All right.
It's like you have nanny cam on your telescope. Just
Yeah, I have too many windows open here. Forget which one I'm in.
I feel your pain. It's okay.
Anymore, I have trouble doing one thing at a time. There it is.
Ta-da!
That's just 10 seconds.
Awesome.
Wow.
So it did come out good. And here's the pillars. Let me
Zoom in.
zoom up a little bit.
There we go.
Pillars.
There you go.
Nice.
So, so who wanted that? Greg, you wanted to see the Pillars of Creation. So this is the Eagle Nebula, which is located in the constellation of Serpens, and there you can see sort of how big the Pillars of Creation are inside the overall nebula. This is perfect. Like,
And
this
I'm
is
doing
learning right here, right now.
I'm doing a 60-second on it, so we'll see a little bit.
Okay, yeah, and then we'll wrap up on that. So while we're sort of getting this last 60-second image, and we'll sort of start to wrap things up. So a big thanks, Gary and Howard and Mark and Mictchell for pointing your telescopes and showing us the night sky. I really appreciate that. And thanks to Pamela and Scott for joining me to provide the color commentary. So we do this every Sunday night. From whenever it gets dark on the West Coast till we've had enough. So usually take about an hour or so. And so in the wintertime we start a lot earlier, and in the summertime we have to start later because that's just how it works. We've got astronomers that are located around the world, depending on the night. We've probably got about 20 astronomers who participate at various times. So people on the West Coast, people on the East Coast, people in Asia, people in Australia, Europe. So it's just great. And then we also record, if you enjoy this, we also record Astronomy Cast on Mondays at noon Pacific. And we also have a gathering together of science journalists, space journalists on Thursdays at 10 a.m. Pacific. And then on Wednesday afternoons we do the Weekly Science Hour, and that's with Pamela and sometimes Emily Lakdawala and sort of bring in scientists and talk to them about space and astronomy. So it's great. We've got lots of great stuff. If you like science and space and astronomy, we've got tons of great shows that you can watch. So can you zoom right in on that, on the pillars there, Gary?
I can.
Perfect.
Pixelated.
Yeah, a little pixelated.
Bend.
Yeah. But that's what it looks like.
There.
That's great. It's great to put it in context like that.
Yeah.
Yeah, I like that a lot.
It amazed me when I started doing this.
Cool, it's because you see that classic picture from Hubble, but you don't really get an idea of what the whole structure looks like. But this is what it looks like, and how much of a small component of it that it is. Really makes that image from Hubble just so much more amazing. So. Cool. All right. Well, I said all the goodbyes. So thanks everyone for joining us. We really appreciate it, and we'll see you all. We'll see you all next week.
Take care.
Thank you.
Bye-bye.
I want to say you're
Bye-bye.
very welcome and good night. No, I'm not going to switch to me. So.
All right.
Good night,
See you
y'all.
later, Gary. See you, everyone.
Good night.
Good night, all.